Hey, Math 20s. This is the third lesson in that Angles and Triangles booklet. So it says at the top, angles in triangles. So the last 2 days we've been working with parallel lines and kind of coming up with some of those statements that we have that we can prove. So things like interior opposite angles are equal, exterior opposite angles are equal, corresponding angles are equal, interior angles on the same side of the transversal are supplementary, vertically opposite angles are equal, and so on. And now we're going to kind of add in some rules related to triangles. So we'll see how those two-column proofs are continuing today. Suppose I didn't turn on the pen part. So there we go. Okay, so we're going to look at this one. So you can see my two-column proof looks a little bit different now. Now I don't have boxes. Usually I'm not going to have that laid out for you, so you just draw it out. So the statement that you're making and the reason for it, or your justification, or your proof. So it says in the diagram, angle MTH. So remember, you guys would have done some of this stuff in Math 10. So the way that we figure out what angle MTH is, so you start at the first letter and you go down to T, and then you go to H. So angle MTH is going to be this angle. It's always the angle that's at the middle letter, so it's the angle at T, but you can see that if I erase this, there's multiple angles at T. So this is an angle at T, this is also an angle at T, so we need to define which angle we're actually talking about there. So we're talking about MTH. So it says angle MTH is an exterior angle of triangle MAT. So triangle MAT. Whoa, it linked that for me. It says determine the unknown angles in triangle MAT and write them out on the diagram. So again, we have the angle at MTH. We have the angle here at M, or we could write it as AMT to tell us kind of which part of the angle that we're talking about. So we're going to kind of just look at how we can justify things and how we can explain out things. You might be able to figure it out really fast in your head, but again, we're going to be looking at kind of those some specific proofs and things that we know definitively with a triangle. So I'm going to start with a statement. Again, writing on the tablet, not the best. Angle MTA plus angle MTH need to be equal to 180 degrees. So that is the two angles that are at T, MTH being this outside one, MTA being this little inside angle. We know that they need to be equal to 180 degrees because angles on a straight line are supplementary. Again, that's add to be equal to 180 degrees. So that's kind of the statement that we're going to make. So now I can math it a little bit. So just substituting in pieces of information I know. So I don't know right now the angle at MTA, but I do know MTH, right? MTH is this exterior angle, so it's 155 degrees. And so that's equal to 180. So if I subtracted 155 from both sides, I know that angle MTA would be equal to 25 degrees. If you need kind of the reason for that, so just substitution and solving. So again, I've just substituted in that value, and then I solved for MTA. Sorry, I'm going to run out of room here. This is not the best. So our next statement that we can make, this is something that you've already known, but so angle MAT plus the angle at MTA plus the angle at AMT equal to 180 degrees. So again, MAT would be MAT. So this is angle MAT. Angle MTA. MTA. So this one is angle MTA. And finally, the last one is AMT. So starting here, AMT. So that would be this angle here. And what I'm saying is they're equal to 180 degrees because the sum of interior angles in a triangle is always 180. We're just going to have to ignore this line for right now. So now I'll do kind of my substitution and solving based on which pieces of information I know. So obviously I know MTA. If I look back up at my diagram, I also know angle AMT. So let's do kind of some substitution and solving. So we don't yet know angle MAT, but we do know MTA was above. So MTA was 25 degrees. And from the original diagram, angle AMT was 40 degrees. So again, if I subtracted 25 from both sides and subtracted 40 from both sides, I would end up with angle MAT equal to 115 degrees. Oh, just hang on one second, guys. Hang on. Yeah, go look on the table down there. Sorry, I have interruptos, of course. So again, kind of my justification. Substitution and solving. Is what we were doing through those steps. So, have we figured out all the angles in the unknown angles in MAT? Yeah, I think so. So we know that this one was 40. This one was 25. I can't quite fit it. And now we know the angle at A is 115 degrees. So yes, we have figured out everything that we need. So now, hopefully, I'll just let you write down, maybe pause it quick and write down what you need, because I'm going to erase that last part so I can erase, or so I can do the question that I'd erased out. Excellent. Oh, excellent, buddy. Okay, keep cleaning up downstairs, please. Excellent. Okay, what are you going to do now? I'm just actually doing a lesson, buddy. Sorry, I know no time passed on your end, but that's okay. So it says, what do you notice about the measures of angle M, angle A, and angle MPH? So we're kind of flipping between multiple different notations. So just to clarify, because now we're not doing the three-letter notation, but we're talking about a couple different pieces. So up here, the angle M is this angle. Angle A would be this angle, and MTH is this angle right here. So it's saying, what do you notice? So the angle at M was 40 degrees. The angle at A was 115 degrees. And the angle at MTH was 155 degrees. And so hopefully you can kind of see, if we add those two together, it is equal to that. So if we add the angle at M and the angle at A, we get the angle at MTH. And so we haven't really derived why this is true, but we're going to see that this statement that we're kind of making here is always going to be true based on question 3. Yes, we'll do it in question 3. I might actually go to question 3 before I go to question 2. So let's just shake your way up there. So it says determine the relationship between an exterior angle of a triangle. So I guess I didn't really define it on that last page. So it says angle MTH is an exterior angle of triangle MAT. So what an exterior angle is you just continue the line out from the triangle, and it's the angle that's made from that. So that's an exterior angle. We also could have an exterior angle like this here. So there's lots of different exterior angles that you can have. We could have an exterior angle right here and that sort of thing. So there's lots of different exterior angles when we have a triangle. So that's what an exterior angle is. So back to question 3. So determine the relationship between an exterior angle of a triangle and its non-adjacent interior angle. So this is what we were actually doing on the last one. So this is an exterior angle. Exterior angle. So again, we've taken this line segment of the triangle and just continued it outwards. So it's an exterior angle. And if we were looking at its non-adjacent interior angles, so that's saying not beside, right? Non-adjacent means not beside. So this would not be it because that is adjacent. So we're looking at the relationship between this angle and this angle to this exterior angle. So what we saw in that second part of question 1, we saw that if we added the values here and here, it was equal to this value. And we want to see if that's true in every case. So what you see with this triangle is we're not actually given any values. We're not given measures. I'm not going to grab a protractor and see what the actual value is. What we're going to do is prove it algebraically. So we'll look through it, and then again, we're going to have kind of another proof in our whole system. So I'm going to be writing out big kind of letter groupings to tell you which angle I'm talking about. So make sure you know what I mean when I write it like this. So the first portion, angle ACB plus angle ACD needs to be equal to 180. This is essentially what we did in that first question. So ACB plus ACD, saying that these two angles need to be equal to 180. So that should make sense because they are on a straight line, and angles on a straight line are supplementary. Probably going to have to erase that in a second, but angles on that straight line are supplementary. So now I'm going to do something that's not going to make any sense now, but I'm still going to do it, and I'll show you as to why later. So what I'm going to do is rearrange this formula just to isolate this portion. So in order to isolate that portion, I'm just going to subtract angle ACB from both sides. And so what I'm going to have is angle ACD is equal to 180 degrees, subtract angle ACB. So I've just rearranged the above formula. To isolate the angle ACD. So this won't make sense as to why, but again, I'm showing you the proof of it so that we can use it in the future. So the next piece of information, so again, we've said that this little angle and this big angle need to add to 180 degrees because they're on a straight line. So now let's deal with triangle ABC there. I'm just going to erase this because I need a little bit. So looking at triangle ABC there. So we know all of these angles. So the angle here, plus the angle here, plus the angle here, they need to add up to 180 degrees because angles in a triangle will add up to 180 degrees. So I'm going to write that. So angle BAC plus angle ABC plus angle ACB needs to be equal to 180 degrees. And again, our reason for that is interior angles add to 180 degrees. I'm just going to kind of erase this because it's making it a ridiculous mess right here. So again, I'm going to take a step that's doing a little bit of rearranging above. And what I'm going to do is I am going to subtract angle ACB from both sides of the equation. So now what I have is angle BAC plus angle ABC is equal to 180 degrees subtract angle ACB. So that's what I'm doing. And so now, because I have to live in color, I'm going to feature something that we have in both of these two equations. And so since both are equal to 180 degrees, subtract angle ACB, we can set them equal to each other. Which is essentially what I called previously the transitive property. Sorry, just give me a sec. Okay, so that's the transitive property. Sorry, I can go back to full screen. I just wanted to kind of highlight, as you see, both are equal to each other, so now I can set them equal to one another. So I can say angle ACD is equal to, I like that it kept it green, so I can say that this portion is equal to this portion because they're both equal to the same thing, so they need to be equal to each other then. So angle ACD is equal to angle BAC plus angle ABC. So, sorry, I'm kind of running out of room here. You're probably running out of room on your sheet as well. But what we have proven, it's kind of hard to see now. So angle ACD, that's this exterior angle, is equal to the sum of BAC, so that's right here, and ABC. So we have now actually shown that the relationship between it. So an exterior angle okay. Yeah, make sure you wash them, okay, bud? So an exterior angle of a triangle is equal to the sum of the non-adjacent interior angles of the triangle. So again, the measure of this, I know it's hard to see because I'm drawing in the same spot, the measure of this angle will be equal to this angle plus this angle. And we've actually proved that that's going to be true in all cases, right? At no point did I use numbers. I have proved it algebraically. So now we have that. That one's kind of a hard one to remember, but again, an exterior angle of a triangle is equal to the sum of the non-adjacent interior angles of the triangle. So now this is back to question 2. It says if you are given one interior angle and an exterior angle of a triangle, can you always figure out everything else of the triangle? So I'm just going to X out of this. I feel like I need color for this one. I also need shapes. Shapes. Let's see if it'll be a friend and let me do this. No, that's not what I want. Yeah, this will work. Just do it from this. All right, look at how great that is. Man, I'm good today. So I'm going to label this outside portion X. So that represents this. I'm going to call this angle, we'll start here, A, B, and C. Okay, so it's saying if you're given one interior angle and the exterior angle of the triangle, so this is going to be based on how I draw it, you're always going to be given X and one interior angle. So this is going, if you're given A, B, or C. If I'm given one of those an X, can we always figure out everything else for the triangle? And it says, oh, explain using diagrams to prove it using logic. So we're going to say if X is given with A, so if we're given X and A, we can't actually determine the exact values of B and C. We just know that B plus C would be equal to X, again, because of what we proved in question 3 there, that the exterior angle is equal to the sum of its non-adjacent interior angles. If X is given with B, we know that we could figure out A. So what we could do is 180 degrees subtract, subtract X would give us measure A, right? Because this is a straight line. So if we had X, we can always figure out A by 180, subtract X. And then we could figure out B. So once we know A, we can go X, minus B, because we know B, right? It's telling us right here we know B, will get us our value for C. So if we're given an exterior angle like this, and we're given B, we can figure out A, and then we can figure out C as well. We also could have done 180, subtract A, subtract B, multiple ways that you can get to there. Sorry. And then C is kind of the same idea as B. If you were given C, you could figure out 80, or sorry, you could figure out A, 180 minus X equals A. And we could figure out B by X minus C, because we know that the sum of those would be equal to, the sum of B and C would be equal to X. So yes, as long as you're not just given X and A, you can figure out the rest. All right, one more question, and then I see one of those key pieces of information. So this is one where we have values and we need to figure out other pieces of information. So this one's a bit of a, it takes a little bit of work and a little bit of reasoning, because we're actually tying together our stuff from parallel lines, because you see there's these two things. So we have parallel lines, and then we've got a whole pile of triangles all over the way. Oh, can you just turn it down a little bit, Hudson? Down, please. You can probably go up one tick. That's okay. Okay, so determine the measures of NMO, MNO, and QMO. So we need to figure out what those ones actually are. So NMO, so you start at NMO, so we need to figure out this. MNO is going to be right here. and QMO. It's going to be this angle right here. So we might find out some other pieces of information as we work through it, and know that this one, I even wrote myself a little note that says there are multiple ways to solve this. That doesn't mean there's multiple right answers. There's just multiple different proofs that you can do or statements that you can use that will get you to this. So I think this question is actually on page 89 in the textbook. Um, Sorry, that's supposed to say multiple paths, but it got crazy. So there's multiple paths that you can take in order to solve this one. So let's look at kind of pieces of information that we have. So again, we have two parallel lines. So like the line between M and Q is parallel to the line between N and P. It doesn't tell us at any point that this line is parallel to this line, so we can't make any assumptions like that. So I'm going to try to erase it. So there's no little ticks on there. Remember, there were the red ticks here. So I didn't just put those on. Oh my gosh. So let's see. Again, I'll just take one route. You can look at 89 because there are other ways, or if you want to just pause this and see what you can kind of figure out on your own, try that, see what you can figure out, and then again, we'll go through how you can justify it and how you can make the statements to prove how you know these particular pieces. So I started out with angle, I said angle LMN is equal to angle MNP. So looking at what that is, so LMN is this one over here, MNP is this one over here. And so the statement that I'm actually using, so I'm using stuff from the previous day, the reason that I know those are equal is because alternate interior angles are equal if the lines are parallel. So since we know that these two lines are parallel, it tells us that our alternate interior angles are equal. That's one of the theorems that we had the other day. So now I can do kind of some substitution based on pieces of information that I have. So angle LMN I'm actually given, so that is 67 degrees. And I'm given a portion of angle MNP, right? I'm given this little portion, but not the rest of it here. So what I can say is 67 is equal to 20 degrees plus angle MNO. It's the 20 again. Let me erase some stuff so you can see it nowhere. So we know that this whole angle, needs to be equal to 67 degrees, but we've already accounted for 20 degrees right here. So if I rearrange that, I would get 47 degrees, again subtracting 20 from both sides, is equal to angle MNO. So we've substituted in what we had and solved for MNO. That was one of the ones we needed to do. So yay, we're done that angle. So I'm just going to write that on because I might actually need it a little bit later. Actually, I'm going to do this a different way than I usually do because, again, there's lots of ways. So this is 47 degrees. So what I was just kind of thinking about now, if we look at this triangle, so I have a triangle right here that I'm drawing in red. I have this angle equal to 47 degrees, this angle equal to 39 degrees. So I can pretty easily figure out that because we know the interior angles will add up to 180 degrees. So we know, again, I'm going to not just write, oh, it must be this. I'm going to write out my whole process for what I'm actually solving. So the angle at NMO plus the angle at MNO plus the angle at MON is equal to 180 degrees. So that's the angle at M in the triangle, the angle at N in the triangle, and the angle at O in the triangle. Add to 180 degrees because angles in a triangle are supplementary, or add to 180 degrees. The interior angles in a triangle will add to 180 degrees. And so now, again, substitution and solving. So we know a couple of these. So I know angle MNO, which is this one, is 47 degrees. I know angle MON, sorry, I'm pointing and I realize MON, that's equal to 39 degrees. So our current unknown is angle NMO. So I just, again, what I've done at this step is just substituted in the values for the two that I know. Now if I subtract both those values from both sides, I get angle NMO equal to 94 degrees. I just need to drink. All right, so NMO, that was one that we needed as well. So we're done 2 of the 3. The last one we're looking for is the one right there. And so again, I'm going to erase some stuff, pause it if you're waiting. Okay, so, oh, I guess I shouldn't erase a portion of that. What did we just call this? So this angle is 94 degrees, and what we're looking for is this last little chunk. So QMO is the angle inscribed within there. And hopefully you can see we have a straight line right here. Again, there's lots of ways that you can actually solve this one. So we could do interior angles on the same side of the transversal are supplementary. I'm going to do this whole big thing. So those are angles on a straight line. They need to add up to 180. So if I look at what those would be called, sorry, I need to use my sheet, so I'm scrolled down a little bit. So I need to use angle LMO. So that's this one, LMN. God, I tried to draw that. That would have been weird. LMN plus the angle that's kind of in the middle here, so NMO. Plus that angle at QMO. We know that they need to be equal to 180 degrees because they are all on the same straight line. So straight line theorem, measures will add to 180. So again, substituting in the known values that we have. So we did have LMN, so that's the one we were originally given, that's 67 degrees. NMO we figured out right here, that's 94 degrees. QMO is our last unknown. So now subtracting 67 and 94 from 180, we get the angle at QMO equal to 19 degrees. Sorry, I was just looking, that looked wrong, but I think it's right. Um, all right, so I just wrote at the bottom the measures. You might be out of room. It's a big one. Of the angles are. And so again, MNO was 47 degrees. Not Rena, but and angle QMO was that last one we figured out was 19 degrees. So we solved what the question was asking us up the top there. But again, look, oh, sorry. So there's other routes to solve that. You're going to get the same answers. You shouldn't get a different answer, but you can use other theorems and other pieces of information. So it's good to kind of recognize different ways that you can view that and solve it. But yeah, there's lots of different ways in that particular question. So we've added in just kind of the two things with triangles. So again, if we look at an exterior angle of MAT, you want to just extend the arm of one portion of your triangle. And then looking at the non-adjacent interior angles, the sum of the two non-adjacent interior angles will be equal to that exterior angle if you extend that arm off. So here you can prove properties of angles and triangles using other properties that we've already proven. And so this one I didn't even really explicitly talk about because we already know that the angle at A plus the angle at B plus the angle at C, if you add them up, it's going to be equal to 180 degrees. The measure of any exterior angle, so again, this is an exterior angle, is proven to be, we proved that it was equal in that question 3, to the sum of the measures of the two non-adjacent angles. So whatever this angle is, if we added this plus this, it will be equal to that same value. So that's now kind of a theorem that we could use. I didn't end up using that on that last one, but I'm sure there was a way to kind of add that in. So that's the lesson. Your textbook questions related to this are on page 90. So it's 3 to 5, 7 to 11, 14, and 15. So look at those questions and think about how you can reason it. And that is all.